Hi, so let's spend a few minutes talking about computer software. Do you know what that is? You might think you know what that is. I know you use it all the time. Like pretty much every time you turn on your computer or use your cell phone or maybe even start your car or your coffee maker, you're using computer software. My digital camera has computer software in it. My smart TV has computer software in it. It's almost like being a fish in the ocean. Like you're surrounded by water, but you don't, I would imagine, if you're a fish, know exactly what that is. So, computer software is something we're surrounded by all the time, but I'm not exactly sure you know what that is. So, let's talk about that for a few minutes. So, let's start off right here. Let's play a Mad Lib. Now, the way we're going to do this is you have to pause the video when I'm done reading this out and fill in the blanks. Okay. And we'll see how close you get, but you got to do your part. You have to pause the video. Okay. So here's a nice definition or explanation of computer software, but you have to fill in the blanks. So if you've ever played Mad Libs, you know, normally you don't get to actually see what the words are. Okay. But I'm going to give you a little bit of a hint here. So N means a noun, ADJ means an adjective, it describes a noun, V is a verb, so it's an action word. So come up with these words, just write them down on a list, okay, before you go to the next slide. So we don't speak a computer's language. We need a blank noun to make the computer adjective. Software is just a set of nouns that tell the computer exactly what to do. Cell phones, cameras, and cars all have nouns. Every day, we rely on software to bring machines to life and make them blank and useful. Okay, pause. Are you paused yet? Still paused? Okay, I'm going to assume you have your list. Let's jump to the next screen and see how to fill this in. So we don't speak a computer's language. We need a translator to make the computer useful. Software is just a set of instructions that tells the computer exactly what to do. Cell phones and cameras and cars all have software. Every day, we rely on software to bring machines to life and make them personalized and useful. So take a second, if you have a smartphone, take a second and look at your smartphone. I'm going to grab mine. Here's mine right here. Okay, got my phone. So I got all these apps on my phone, ton of apps on my phone. Pages, actually, and pages and pages of apps. I don't know if you can see them. Anyhow, I have too many apps. And then I have folders that have more apps in the folders. Does my phone look like your phone? Does your phone look like my phone? I don't think so. Like, what would the odds of that be, right? That would be really weird and unusual if our phones looked the same. And so that's the personalized part. The apps or applications, that's just, like in the olden days, we used to just call it computer software or programs, and now they call them applications or apps, probably because it's just easier to say, but it's all the same thing, okay? It's a set of instructions that tells the computer what to do. And so I'm looking at my phone. When I click on this weather app, something happens. What it does is it goes and pings the Weather Underground website and it pulls up all the different measurements. Like right now, it says it's 89 degrees out there. I think somebody didn't get the memo that it's October out. I'm looking out my window. Anyhow, so applications personalize your device, but they also make it really useful because without software, wouldn't it just be a chunk of, I don't know what, metal and wires and circuits? Like it wouldn't really do anything, right? So we don't speak the computer's language. The computer doesn't speak our language, and the software translates it. Now, when we get to the programming chapter, we'll dive in deep on what that means. We'll look at some binary, we'll look at some other things. But for now, just kind of think of software as a translator. It helps the computer do what you want it to do. So There's several videos alongside with this slideshow that I'm not going to watch in this video. Like I'm not going to do a video in a video for the most part, but they're really interesting. And this one's only about, I think, 2 minutes long. And it's from GCF Learn about how to understand applications. And it gives a really nice overview of different types of applications. So make sure you go back and watch the video. But for now, let me just break this down for you because software kind of falls into 3 main categories. There's probably a few other categories maybe, but these are the main categories, okay? And so at the very bottom, and I'm going to go like, I know this is reading backwards kind of weird, but I'm going to go from right to left. So kind of at the bottom layer is operating systems. And you need an operating system to interface between you and the hardware. And we're going to talk about operating systems in detail in just a minute. So I'm not going to go too much deeper into that. The next layer of software is this utility software. And so this usually comes bundled with the operating system. You might see things like if you have a Windows machine, you might see defrag or ways to set your monitor, like device drivers, things. These all kind of fall into utility software. If you go to hit print, you have to have a print driver that interfaces with your printer. So in this category would things be software that interfaces with peripherals. So printers and monitors and projectors and microphones and speakers, scanners. There's all kinds of things you can plug into your computer, right? And you almost always, when you do that, have to install something. And so those are device drivers and they kind of fall under the utility software category. Okay. These are things that just help make your machine a little more efficient. They let you do some extra things. By far, however, the largest category of software is application software. Just by looking at your phone, like if we just did a count, we had a contest and we just said, okay, count up how many apps you have in your phone. Okay. Actually, I think there is a utility software on your phone that lets you check how many applications you have and how much space they're taking up. So that's one of the things utility software can do. But anyhow, I would guess you probably have, I don't know what, 20, 50, 100 different programs, maybe more on there. But these are the programs that interface with us, okay? So the other two kind of interface with the machine itself, but the application software, that's what we use. That's what makes it useful to us, okay? And so we're the end user. And we'll take a look at a couple of different types of those, but there's a huge variety. Like it's almost endless, the types of application software that is available. So this is another take a break moment. What I want you to do is pull out, I don't know, like pull out paper and pull out a pen or use Notepad or some note application on your phone or something and list how many types of software you can think of. Now be a little careful here because a type of software isn't necessarily a specific software program. And I'll give you an example. So I'm just looking on my phone. So the first thing I see is Google Podcast. Okay. Now Spotify does this also. Um, there's a whole range of different apps that let you listen to podcasts. iTunes, you can listen to podcasts. There's several others. Okay. The type of software is podcasting software. Okay. But the individual application might be Google Podcasts. What's another one I have on here? Music applications. So I have Amazon Prime Music. That's what I listen to the most. And I have something called Rocket Player, which is a media player for my music. But there's also iTunes and also Spotify and Pandora. These all kind of fall into this category, right, of music software. So a specific program might fit under more than one type, like it might categorize as more than one type. What I want you to do is think of how many types of software and start off by just looking at your phone, but don't get limited to your computer or your phone. Like think about your car, think about your kitchen, think about when you go to the grocery store, think about when you go to the bank. What are the different types of software? And just make a list. Let's see how many you can come up with. So we're going to pause this, or I'm going to let you pause this, and then we'll come back in just a minute and break this down just a little bit. Did you pause it yet? All right, make sure you paused it. Keep going. I bet you could get over 20. I've had people get over 30 or 40 different types. All right, I'm going to assume you're back. Let's go. So I want to give you a couple of examples because I think a lot of people get really confused about this. And so I've heard this a lot. Actually, I should show that. Let me jump to the next slide and then I'll come back to this slide. So this is what I've heard a lot. I frequently ask students, so what web browser are you using? Okay, so the category is web browser. And a web browser is just a piece of software that lets you get on the World Wide Web. Now, remember, we talked about the internet versus the World Wide Web several weeks ago. There's a whole video on what the difference is. But if you remember, the World Wide Web follows the HTTP protocol, Hypertext Transfer Protocol. Okay. And so a web browser follows that protocol. It lets you open web pages. You can click on hyperlinks. You can download files. You can do a whole bunch of other stuff, right? Because it's kind of bundled in with media players and lots of things now. But anyhow, that's how you know it's a web browser. You know, the URL up at the top, if you want to go to a web page, it'll be http:// something, something, something. Okay. Remember, we talked about that in another video. So here's what I hear a lot. I ask students, so what web browser are you using? And they'll tell me, I'm using Google. Okay. Google's not a web browser. Google's a really big company. They do search software. They do web browsers. They have Office applications like Google Drive. There's Google Photos. Like, so Google isn't the web browser. The web browser is Chrome. Google's a company that makes Chrome. Okay. Same with Firefox, Mozilla Firefox. Okay, so Firefox is the name of the web browser. Mozilla is the company that develops it. Apple makes a web browser called Safari. I happen to have all three of these on my computer. I have one more actually. I have Opera, and I almost put this on the list, but I couldn't find the company name. I sort of think it's just the Opera Foundation. So I guess I could have put that. But anyhow, it wouldn't have been as clear. So keep in mind the company name is not the application name. So another example of that is in word processor. So what does a word processor do? Okay, we kind of talked about this a couple weeks ago. A word processor lets you process words. Okay, so you create a page, and on the page, so it's very much like a book or something, right? You create a page, and on the page, you have lots of words. You can insert pictures and charts, but you can't insert videos because a page is meant to be printed, and you can't print a video, right? You can print a picture, but not a video. So that's kind of a weird thing. Um, you can format the text, you can do spell check, you can make things like columns, you can do little, editing, you can copy and paste. These are all things you can do in any word processor. How they might be done might vary a little bit from one to one, but the category is word processors, okay? And again, the company name is not the same as the application name. So Microsoft's word processor is called Word. You almost always hear it like together, Microsoft Word. What are you using? Microsoft Word. Same with Google. Its word processor is called Docs, but you usually say Google Docs. But if somebody says, what's the application? You say Docs. Apple has one called Pages. Open Office has one called Writer. I mean, there's a whole list there's lots of different ones, okay? But it's the same sort of thing as with the web browser. So let me jump past the web browser slide. Let's look at a little bit more of a complicated one. Okay, so this category is office suites. And all a suite is, it's not like a really nice room in a hotel somewhere at the top floor. That's not a suite. Okay, that is a suite, but that's not the suite we're talking about here. What we're talking about here is a package of software that combines. So when you get the package of software, it combines several different programs. Okay. And so Microsoft Office. So these are all Office suites, Office productivity, except for I couldn't fit that word in the same line there. So Microsoft Office, Google Drive, Apache Open Office, Apple iWork, All of these have at least 3 of the same types of software. So they all have word processing, they all have spreadsheet, and they all have presentation. And they might have a few other bells and whistles. So a couple of them, like Office has a database called Access. Okay. And I think Open Office's database is just called Base, I think. So they might have a couple of other things, but typically Office Suite software has those 3 things. And the advantage of using the suite of products is they usually interact really well. So for example, you can create a spreadsheet in Google Drive, in Google Sheets, okay? And then you can create a document, a Google Doc, and you can import the spreadsheet into the document and have it update in live time. So if you go to update the spreadsheet, the document will update also. Well, that's kind of nifty, okay? So there's lots of little interactivities that go with an Office suite. I'm going to show you one more example that's a little bit different, just to drive this home. So in this slide, the company name is the same. It's all Adobe. Adobe has a ton of applications, okay? And I could put 10 more things on here. But Adobe Photoshop is in the category of photo editor. Adobe Acrobat is in the category of a PDF editor. You can create PDFs, edit them, annotate them. You can do all kinds of things with PDFs. Acrobat Reader just lets you read them. So you may have opened Acrobat Reader if somebody sent you a PDF of something, but you can't really do any editing. You need the actual Acrobat program. Adobe Premiere is a really good photo editor or video editor. And Adobe InDesign is a desktop publisher. Okay, but they're all Adobe products. It just has lots of different applications. So what I'd like you to do, let's back up to this slide. Now that you kind of have that schema in your brain, think again, go back to your list. How many different types of software can you think of? Word processor, spreadsheet, like what are the categories? And then see if you can do like a sub list. So within, I don't know, let's say music program, music software. There's 2 types, right? There's listening software and there's creation software. So GarageBand would be a creation software. Oh, what's the other one? I just blanked out. There's another one that we were just talking about that's a free open source. Starts with an A. Anyhow, I'm sure you guys will figure it out. Anyhow, so kind of split your category: music creation, music consumption. And underneath your categories, see if you can list out how many applications can you get? Like how many music ones can you think of? How about games? Can you split? And you can probably split games into categories, right? So you've got FPS games and you've got I don't know, like card games and all kinds of arcade games, different types of games. And under each of those, what could you list out as far as specific titles? I'm really curious to see who comes up with the most. And if you submit me a list that has, I'm going to say if it has over 15 categories and 100 different titles, individual software names, kind of split up pretty evenly. Like you can't have one category have 50 items. Submit that to me in a Google Doc. Make it neat, make it easy to read, put your name on it, and I'll give you some extra credit for that. Okay. That was a spur of the moment extra credit. So come up with a list of all the categories and then sort of like this, word processors, list them out, and web browsers, list them out. Okay. Office suites, list them out and see what you can do. At least 15 different categories. I know that sounds like a lot, but I could think of a ton. Okay. Educational software, financial software. I'm not going to give you too many of them. And you can list out probably 5 to 10 applications under each of those categories easy. So let's jump on and let's talk specifically about operating systems. This is one of my favorite ones, okay, favorite topics. And I kind of have this silly little cartoon, and I want to say it sort of looks like it's from a Berenstain Bear, or Richard Scarry, probably Scarry, cartoon. And I like to describe an operating system. And remember, I said that was kind of like the base level software on your machine, on your device. And all of your devices have them. This hasn't always been the case. When we talk about computer history, we're going to go back to a time when there were no operating systems, and that was a little chaotic. But thank goodness we have operating systems now. And here's why. The operating system's kind of like the traffic cop of the computer for lots of different reasons. So I want you to imagine for a minute, think of the busiest intersection where you live, like close to where you live. What's the busiest intersection? Most traffic, tons of stuff there. Got it? You got what you're thinking about? Okay. What would happen if the power went out and all the lights went off? Just picture that for a minute. What would happen? Like for here, the one I always think of is Amargosa and Bear Valley Road, because that's a horrible intersection on a good day. Okay. And if you're on Amargosa and you're trying to cross, there literally is a 3-car light, mostly like a 2.5-car light, right? So you barely squeak through there. And if you're 15 cars back, it's going to take you a while to get through that intersection. Anyhow, but imagine if the lights went out. That would be nuts. People are supposed to, like, y'all took the driver test if you're driving, right? You're supposed to, in an orderly manner, give right of way, and everybody's supposed to do the right thing. But what actually happens? Somebody tries to squeak in, somebody else goes around, somebody's not paying attention, somebody crashes in the middle. It doesn't work out well. So what does the city do? The city sends out a traffic cop, whoever pulled the short straw in the meeting that morning. You know, they said, okay, you got the short straw. If there's something dumb that comes up, you have to do it. And so they send that guy out to the middle of a busy intersection with a whistle, and he does what this guy's doing. But honestly, it's a super critical role, right? Because what does he do? He says, okay, you guys come, come this way for a few minutes. Now stop. Now you guys go for a few minutes that way. Now you stop. And basically, he controls the flow of traffic so that everybody gets to where they need to go quickly and efficiently, or more so than if they were doing it on their own, and so that nobody crashes and gets hurt. Perfect metaphor for an operating system. An operating system manages resources. It connects in the peripherals, like it makes all the hardware connect in together so that everybody knows what everybody else is doing. It sets the interface design. Like if you sit down at a Mac, even if you've never used one before, you can probably tell it's not Windows. Now, how do you know it's not Windows? Well, because it does a few little different things. The interface is a little bit different. In my Mac, the minimize buttons, there's like 3, right? Close, minimize, and maximize. That's in the left-hand corner. On Windows, where is it? It's up in the right-hand corner. Okay. I mean, there's just lots of little interface things like that that you don't think about until you use a different operating system. And then you're like, oh my goodness, how do I minimize this screen? Okay. So the operating system controls all that. And what's nice about that is that if a programmer doesn't have to reinvent the wheel. Back in the olden days, back in the days before operating systems, if you wanted to make a computer work, you had to learn the system on that machine. And it was different than the system on the other machine, okay, or any other machine. There was no consistency. Now, if you want to write a program for a Mac computer, there's a certain set of rules. There's an IDE, okay, an integrated development environment, that will help you with kind of almost plug and play the pieces that provides, what am I going to say here? Like the framework of what a program should look like, how the buttons look, what things are on the menus. So, if you click on, let's say you click on the edit menu on almost any program, what are you going to see? Copy, paste, find, there's several different things. If you click on the file menu, you're going to see open, save, print, like there's different things, right? So the operating system controls that part of the interface. Another super important thing the operating system does is it interfaces with the other software and the hardware. So remember that system software part that we talked about, okay, or the utility software. This graphic on the right describes it really, really well. because the operating system is sort of the glue that keeps all of these other pieces put together in a really nice way. Another thing the operating system does is it manages memory. So try to think about, like, if I just said 10 random words or 10 random numbers right now, and you didn't write them down, and I gave you 30 seconds to listen. Okay. Dog, cat, goat, red, tree, sky, mountain, popcorn, uh, television set. I don't know. I didn't even know if that was 10, right? And I said, okay, give them back to me right away. You could probably get 3. You might get 5. You could possibly get 6 if you grouped them, but you'd have a really hard time doing all 10. Like, you can practice that. You could get good at that. But that's your short-term memory. And when we talk about hardware, we'll talk about this, but that's your RAM, your short-term memory. Because you know how it is, you're counting something and somebody comes along and they're messing with you, and you're like on, 97, 98, 99, and they pop in 42, 112, totally messes you up, right? Because your short-term memory can only hold so many pieces of data. Your long-term memory is what ties things together. And so when you have a software program open up, it uses a certain amount of long-term memory and it uses a certain amount of short-term memory. And if you have too many things open at once, you only have so much memory. And so if there's too many things open, they're going to vie for who gets to use that memory at any given time. The operating system manages the memory. It says, okay, you're up front. They're using you right now. You get the memory, the most active memory right now. You guys, you're kind of in the background. She doesn't have that tab open, so you don't need that much memory right at this minute. And the operating system, like the traffic cop, manages how those things go back and forth. So operating systems are really interesting. This short video, I think it's also a GCF Learn one, is going to talk about understanding operating systems in a little more detail. You know what these logos are? Like, do you recognize what operating systems these are from? Probably Windows, probably Mac, right? What's the little weird guy, green guy? If you have a phone, like my phone is the little green guy, that's an Android, right? Which is a mobile operating system. What about the little penguin dude? Do you know what he's all about? He's awfully cute. Anyhow, there's a number of different operating systems. This video is going to talk about some of them. But what I want to do is talk about the little penguin dude, because it's not as common, well, I can't say it's not as common. Almost every website that you go to runs on this operating system. You just never know it. Okay. So we're going to talk a little bit about Linux. It has a super cool history. And again, when we talk about computer history and programming, we'll get into this a little bit more. We're going to talk about open source software and copyright schemes in a couple of weeks. And so I'm going to wrap some things into that kind of overlap with what we're doing here. But in a nutshell, Linux is an open source operating system. So if I want to get Windows on a computer that doesn't already come with it, I have to buy it, right? Like, Microsoft will charge you for that. If I want to get Mac OS X or whatever the current version is, first of all, it will only run on a Mac. It's proprietary to a Mac, but you have to pay for it. It's wrapped into the cost of your machine. Okay, and if you want to put it on something else, you pay extra. That's proprietary software. Linux is open source, which is a really interesting licensing scheme. Scheme sounds like that's the mafia, like they're going to shake you down, but that's not what that means. It's just a way of doing things. And in open source software, typically somebody starts developing something. And in this case, Linux was developed or started to get developed by a guy named Linus Torvalds. And he was at the University of Helsinki in Finland. He was a student there, computer science student, and he really loved the operating system that they used on their computers and wanted to use it on his own computer so he'd have the same environment. Well, they said, nope, can't do that because, we own it and you don't. So he said, okay, well, I'm a computer science major. Let's just make our own. And so he started writing his own code. Now, where the open source part comes in, as he quickly realized, I can't do this by myself. And so instead of selling the code, instead of putting restrictions on the code, he opened up the source code, the actual programming, so that people could jump in and help. And it's super interesting. It's super interesting. It's, like I said, we'll talk about this in more detail in a couple of weeks in another video. But what makes it interesting is that it's free. So you could go download Linux on your own computer. Moodle that we use for our class, that's free. That's open source software. Um, you could go download Moodle. And some of you actually went to moodle.org or moodle.com instead of boss.vdc.edu/Moodle when you first started logging into the class, because you heard me say Moodle and you just Googled it and that's what came up. So that caused some confusion. But that's an open source software. So you can install that if you wanted to on your own server. Anyhow, what's interesting about Linux is for years and years and years, and it's been out, I want to say since 1991 is when, give or take a year, is when Linus Torvalds first open sourced it. Since then, it became a really robust server operating system. Servers are what run, servers are just big, powerful machines that are pretty much on all the time. So internet websites are run on those, intranets are run on those, lots of gaming things are run on those, lots of things are run on servers. And most of those servers, not all of them, but most of them run on Linux because it's free, which is about as cheap as it gets. And it's easy to maintain at that level by people who are kind of geeky, like the network admins and things. It's pretty easy for them to maintain. The tricky part is on the desktop, like on your laptop or your computer. Um, Linux was not friendly. And I remember because my husband uses Linux on his laptops, and he would just like rant, like, why can't I find a printer driver for my computer? Why can't I find, just lots of different things. That has changed in the last 5 or 6 years. There's been a big push for what they call distros, distributions of a variety of types of Linux. So because the source code's open, people can take it and tweak it to work, to do what they want it to do. And so several distros have come out that are particularly well suited to desktops and laptops. Ubuntu is one of them. That's the one we use a lot. Mint is one that I've heard really good things about, but haven't actually tried yet. Um, they all kind of do the same thing, but they all have their own kind of take on how they're doing things. Anyhow, Linux is really interesting and it's lightweight. So it's a really good way to rejuvenate an old computer. Like you might have an old computer that you cannot upgrade to Windows, whatever's current, because it just doesn't have the space or the memory or the willpower to run whatever's current. You could wipe all of that, put Linux on it, and completely rejuvenate the lifespan of that laptop for another several years. So lots of people do that. So I've got a video here, Linux Explained. This guy talks for, I don't know, 5 or 6 minutes. It's really funny because at the end, like, I don't remember he did this, but at the end, he has a promo for something because it's a sponsored, he's got sponsors, which is good. If you have a YouTube channel, it's nice to pay for things. Anyhow, it's kind of a funny thing because he's talking and talking and talking about Linux. And then all of a sudden, boom, he makes a segue to this other thing. Not going to tell you what it is. You got to watch it to the end. All I'm going to say is, guys, you might find it useful. I don't know. Ladies, I don't think so as much. But anyhow, he does a really nice job explaining what Linux is all about. And then if you want to see what it actually looks like, I'm really sad because Ubuntu used to have a virtual tour set up where you could go to their webpage, their tour webpage, and click around and it would look like the actual Ubuntu desktop. For some reason, about a year ago, they got rid of that. I was so sad because it was really neat. You could click on things and open files and browse web pages and kind of actually simulate your way through what it would actually look like. Because most people are like, well, I know what Windows is. I kind of know what Mac is, but what is this Ubuntu thing? Anyhow, this video will at least give you a visual tour of some of those features. I think it's about a year old, so they might have an updated version at this point, but it does a pretty good job in a couple of minutes of giving you an overview of what at least this version of Linux looks like. What I want you to do when you watch this is pay attention. Like whatever operating system you're used to, if it's Windows or Mac, whatever it is, watch the Linux preview and see, like make a list, like this looks just the same, or this looks really different. They do this differently. Like see, kind of compare and contrast what you see here with what you're used to doing and see what you think about that. So Linux is fun to play with. Back in the olden days, I actually used to burn Linux on a CD and boot up all the computers in the computer classroom to Linux when the students came in, and they just start using it and not even realize that that's what was happening. That's a little harder to do now. So I'm going to finish this off with a little short, well, it's not, I guess it's short. It's only 9 minutes long. But anyhow, I thought it'd be nice to finish this off with just a little peek at what software programmers do. Because somebody writes all this software. Like there's code, right? Somebody's got to make that. And so I was looking up several different videos, and I was super excited to find the video that I found. And again, when we talk about computer programming, we're going to dig in deeper on this. And so she actually has a degree in physics, and she talks about that, but now she's a software engineer. And so we'll get onto the nuance of a software engineer versus a programmer or a tech, you know, when we do the programming chapter. But she has a really fun way, and she's talking to several different programmers about what it is they do. Like, do you just sit there and hack out code all day? I'll give you a hint, or I'll give you it's not quite a spoiler alert, but it's something to pay attention to. You'll probably hear them talk about creativity and problem solving. And that's what makes programming so much fun and makes software so much fun. There are other issues we could talk about here. We're going to talk about copyright and intellectual property in a different video in about 2 weeks because it ties into another topic we're doing. And I didn't want this video to be hugely long. But there are issues of like software piracy. Okay, so if you copy something that you didn't pay for or that you don't have the right to use, who does that impact, right? You know, they're just big companies. Maybe it might be some guy in his garage trying to make a living off of his code. You don't know. And so there's just lots of interesting issues, a couple of which are detailed in the Think section this week. So I hope that gives you a little bit of insight into what software is all about. It's kind of an interesting, never-ending process, but don't forget the extra credit.